What do you know about Jupiter? Jupiter is a huge gas giant, the second largest body in the solar system after the Sun. It is also the planet with the largest number of satellites and is believed to protect Earth from asteroids. However, recent opinions from scientists have changed regarding Jupiter. Let's start with the satellites. If you add up the mass of all the planets in the solar system, they would still be twice as light as Jupiter. This suggests that the gas giant should have the most satellites. However, Jupiter only held first place in this competition for a couple of months. In February 2023, the Planet Center miner announced the discovery of 12 new moons, bringing the total number to 92. But in May, Chemical Union announced the discovery of 62 new moons around Saturn, making it the planet with the most satellites at 145. It is believed that most of Saturn's new moons are pairs of smaller satellites that once collided. This competition for the most satellites leads to a rethinking of Jupiter's characteristics. Scientists have wondered how Jupiter could become so huge and yet remain in balance with the other smaller planets and the Sun. The conservative belief was that Jupiter began its formation in the outer regions of the solar system, where there is a cloud of material that was not useful for planet formation. During its youth, Jupiter was the most distant of the protoplanets and grew by accumulating dust and gas. The constant collisions with debris distorted the planet and slowed it down. Since gravity does not exist according to Einstein's theory of relativity, and we are all simply falling into the Sun, Jupiter lost its counteracting velocity and began to fall towards the Sun. Fortunately, the presence of Saturn and the combined gravitational forces of other planets prevented Jupiter from committing suicide, and the solar system achieved a delicate balance that persists to this day. In 2022, new data from the Juno probe shattered the theory that Jupiter's entire core was assembled bit by bit from pebbles and dust. The data showed that the material inside Jupiter is unevenly distributed. This goes against the expectation that if Jupiter collected material bit by bit, it should have a more homogeneous composition due to gravity. Instead, gravitational anomalies and the accumulation of heavy or metal elements on Jupiter indicate that it has gathered 15 to 30 times the mass of the Earth in these elements. This brings up questions about Jupiter's origin. Initially, Jupiter, like any other planet, was believed to have a rocky composition similar to Earth or Mars. It became a gas giant when gravity became powerful enough to attract even gaseous substances in addition to dust. However, to break through the atmosphere of Jupiter, a larger stone or asteroid would be required. Therefore, in order to accumulate such a huge mass of metal inside Jupiter, it would have needed to feed on hefty asteroids or even protoplanets. In summary, the evolving understanding of Jupiter's characteristics includes its position in the satellite competition, its formation process in relation to other planets, and the distribution of materials inside the planet. Opinions on exactly when Jupiter devoured other protoplanets, before or after transforming into a gas giant, vary. However, in all cases and calculations, it turns out that Jupiter can safely be given the title of planet killer. According to the original drawings of the solar system, there were many more planets designed, but well-fed Jupiter had her own opinion on this matter. Not only did Earth face this issue, as it also collided with a protoplanet at one point and partially absorbed it. However, in our time, for such a dark past, Jupiter and its monuments may begin to be demolished. Moving on to the weather, Jupiter disrupts the harmonious story by acting like an asterisk soul. When you try to educate your friend about the changing seasons on Earth, he rudely interrupts and claims that the seasons are connected to the distance between Earth and the Sun. You laugh and explain that, in fact, the change of seasons on our planet occurs due to the tilt of its axis of rotation. Earth is tilted by about 23 degrees, and it is because of this tilt that we experience autumn, winter, summer, and spring. However, Jupiter has no tilt. For example, its axis is rotated by only 3 degrees, resulting in all parts of the planet receiving more or less the same amount of heat and no change in seasons. But your annoying friend jumps into the conversation and reminds you that, in fact, there are changes in the weather on Jupiter. The weather on Jupiter is another mystery of the gas giant. Since 1978, the VLT telescope in Chile, along with the Galileo and Juno spacecraft, has been studying the planet's weather. The results clearly show sudden cyclical changes in the planet's weather. It was no secret that the cold regions of Jupiter are light in color, while the browner regions are hotter. These changes are visible from the ground, almost with binoculars. However, the unique aspect is that when the temperature rises in certain latitudes of the northern hemisphere, it simultaneously decreases in corresponding latitudes of the southern hemisphere. Unlike Earth, these latitudes on Jupiter are separated by much greater distances, yet the process occurs almost instantly. The reason for these constant weather changes on Jupiter is unclear, but it is being studied in the hopes that scientists will eventually be able to predict Earth's weather at least 15 minutes ahead. All these fascinating discoveries are not limited to Jupiter itself, but also extend to its moons. The moons of the gas giant are famous for individually symbolizing different aspects of Earth's history and its transformation into a living planet. For example, Ganymede is a huge rocky moon with its own magnetosphere and liquid core. It is the most geologically active body in the solar system, with numerous volcanoes across its icy surface. Scientists believe there is more liquid water beneath Ganymede's surface than on Earth. Combining the properties of 3 such moons could create a healthy planet with volcanic activity and water, reminiscent of a second Earth. But enough about these exciting discoveries. The most recent and interesting finding is that Europa, another moon of Jupiter, most likely does not have a core, or if it does, it was formed relatively recently. We are accustomed to considering the solar system as a place where everything formed long ago and is in balance. But the reality presented by scientists, led by Kevin from the University of Arizona, shows that another 90% of Europa's mass is composed of stone and metal, disproving the presence of a liquid core and mantle, elements that every self-respecting differentiated celestial body should have. New simulations suggest that Europa formed under much colder conditions than Earth. Metal and stone in Europe did not necessarily melt. They literally stuck together and froze, possibly under the influence of Jupiter. Under the icy surface, the ocean melted, but a full-fledged liquid metal core could only appear in Europe a billion years after its formation, and it is not certain if it exists at present. Scientists do not deny that the satellite is still in the process of melting its insides and awakening its potential, which may take another 2 or 3 billion years. Therefore, it is possible that we are currently observing a world in the sky that is similar to Earth, but at the very beginning of its journey. By the way, we will find out soon enough. In April, the JUICE apparatus was launched, with the direct mission of studying the satellites of Jupiter. It will reach them and begin sharing content somewhere in 2031. This mission is very important because in recent years, another theory has been gaining popularity. In the last video, we were looking for the most suitable place for life beyond Earth, using traditional methods. Mars, Enceladus, and Europa were considered, but now, many astronomers believe that one of the best candidates for the presence of life may be Ganymede. It all started with the Hubble Space Telescope, which in 2021 detected traces of water vapor in Ganymede's atmosphere. More precisely, this happened in 1998, but at that time, water was confused with oxygen. The discovery itself is not enough to indicate the presence of life, but it strongly suggests the existence of non-frozen liquid water, which is even more than on Earth. This water is mainly stored under the surface at a depth of 160 kilometers. Additionally, more detailed calculations indicate that Ganymede's interior may consist of alternating layers of ice and water. Recently, it has been confirmed that Ganymede, one of Jupiter's moons, has its own magnetic field, similar to Earth's. This magnetic field protects Ganymede from solar radiation. The presence of a magnetic field suggests that Ganymede has a liquid iron core, similar to Earth's, and potentially has hydrothermal springs that could support life. Therefore, Ganymede is considered a reliable place to search for alien life in the Jupiter system. Our understanding of Jupiter continues to grow, and there is much more exciting news to come. Stay tuned for updates and feel free to leave any questions or comments. See you next time.